Hello everyone, my name is Malik and you are watching Malik Robotics. So in this video, we are going to build our first neural network with TensorFlow. So without wasting much time, let's jump to the video. As we have already covered some concept of regression and neural network in previous videos, so we are just going to do some coding and see some visuals. So let's go. Okay. So first of all, before making our what we say neural network, we have to see that what these hyperparameter are and what these does. Okay, so let me open uh yeah, neural network playground. Okay, so here, first of all, first hyperparameter is input layer shape. Input layer shape is nothing is but just the shape of the input which we are providing. It's like if we are providing our image of dog as an input, so its shape is R, G, and B, like 1, 1, 1. So say like sorry 255, 255, 255. So the shape is 255, 255, 255. So the shape of input is our input shape. Hidden layers. So hidden layers are the layers between the input and the output. In this model which you are seeing, there is only one hidden layer, but there can be multiple hidden layer. We can see this using the tensor playground. Okay, so okay, so this is our neural network with only one input and one neuron. Okay, and one hidden layer. But we can increase the hidden layer, like two hidden layer or three hidden layer, and we can increase some neurons. So this is the neuron per hidden layer, and this is hidden layers. Okay, so we have seen what are the hidden layer and what is the neurons per hidden layer. Okay, basically like more neurons means like more calculation power, more hidden layers like more calculation power. And now what is the output layer say? Just like the shape of the input is input shape, just like the shape of the output will be the output shape. And hidden activation. Okay, so you can see that if I say this is a classification program problem, and I have seen I have taken the linear activation, so it is not fitting quite well, because linear activation function can't like use this, but you can see like 10h is quietly fitting more than linear. And if I will use sigmoid, then okay, this is not helping. I think relu, okay, this is also not working. But if I increase the some hidden layer and some neurons, then I think okay, now this is doing some more works. Yeah. Uh, s- Sigmoid activation function is nothing doing. Let's try 10h. Okay. So, this is fitting quite well than the sigmoid, relu, and linear, but this is also struggling a little bit. So, this is our activation function. Now, what are activation and why they are being used, then we will going to cover in the next video. For that, let's skip that. What is activation function is for now. And for your detail, like we apply activation function after each hidden layer and after output layer also. So this is hidden activation means this is after every hidden layer, and this is after output layer. Loss function. Loss function is MSC or MAE or any other. You have basically studied in your high school. In the loss function, what does it give? Loss function give you that how much error prediction is giving, and that is after that there comes the optimizer. So optimizer take loss from loss function and then try to minimize it use by altering the weight and biases. Okay, so this was all about hyperparameters and all about the hidden layers and other things. So let's now build our own neural network. Let's open our Google Colab and okay, let's reconnect the runtime. Mhm. Okay, let's clear the output. And first of all, we will import TensorFlow STF and date time. Okay. After that, this is we will create two variable. One is x and one is y. Both is array, and having some values. So let's plot the value. So this is our x-axis and this is our y-axis. So these are the values. Okay. So now this is our data set which I have made custom. Now what we will do is we will make a neural network, a regression neural network, because this is a new regression problem. Okay, this is a continuous line going up here. So this is a regression problem. Regression is used in continuous problems. So here, what we will do? We will give x as our x label and y is our target label, and we will try to predict y. So let's go. First of all, we will check the shapes. Okay, input shape. There is nothing in input shape and there is nothing in the output shape because x0. What is x0? X0 is minus 7.0. So this is a zero rank tensor. That's why the tensor is zero, as it is a scalar quantity. Okay, and now this is the part where we will do some things. So first of all, we will set the random seed 42 so that we can increase the reproducibility of the code. After that, we will use our tf.keys.sequential layers. So what is tf.cs.sequential or convolutional? We will discuss it in afterwards in this playlist. For this, just remember that we use tf.keys.sequential for making a model. Okay, in tf.keys.sequential we are saying that we have a sequential model. In sequential model we are using one tf.keys.layer.dense layer. Okay, so we are using one layer and the layer have one neurons. Okay, so if we see it in on tensor board, then we are saying that we are having one hidden layer with one neuron and uh, what I say, this is a regression problem. Okay, so this is a regression problem and our activation is linear. And okay, let's go. So this is not helping much because it has only one thinking unit and one hidden layer. But as this is our first model, so this is our layer tf.keys.layer.dense, and here in a hyperparameter we are giving that how many neurons we should have. After that we will compile. Here we will select the loss MAE. Okay, we for regression problem generally we use MAE or MAPE. Okay, for an optimizer we are using .sgg, means stock stochastic gradient descent. I can't pronounce stochastic or like it from the high school. I mumble in saying stochastic, but okay. So I prefer to say SGD also only. What is SGD? We will discuss in the lectures. Okay. So here we will say that optimizer is SGD and loss is loss.MAE and matrix MAE. MAE is mean absolute error. Okay. So in compile function, we give these three things. After that, we just have to fit the model. While fitting the models, we will use just x and y. Okay. We have used tf.expand dims and x is equal to -1 as TensorFlow does not support the scalar vectors, like in the latest update. So this is only for increasing the dims. Okay, okay, increasing the dimension and then taking -1. Okay, this will take only like 2 dimensions from vector, only this part. Okay, so this is nothing, just putting it in other way. Okay, so this is our x, this is our y, and epoch equal to 5. What is epoch? Epoch is how many times the model will train. Like epoch 5 means our model will train by 5 times. So let's fit our model. Okay, so this is pretty fast. Our model is fitted by 5 times with MAE 12.28, 12.1. Like this is pretty much MAE. Let's see what was our x and y. And let's see what is our y pred. Okay, y and sorry, y comma y pred. Okay, so you can see that this from 3 we get minus 3.5. Okay, this is like just negative value, but this is near it. -2, the so these values are doesn't matching at all. Okay, and remember one more thing. Here what we have used, if we did do not specify that which activation function we are using, then it take linear. Okay, so here we are using linear activation function. Okay, so we have used only one neuron and one hidden layer. That's why it's not mapping correctly. But let's see this on normal matplotlib. Okay, so our model is doing not pretty much like regression line should go from like here, and it is going like this. Okay, so in the upcoming video we are going to see that what is activation function and what I say, we are going to study what is optimizers, what are activation function, what is loss function, and after that we are going to improve our model to predict on the right amount of data. So for this video, only this. We will meet in next video. Until then, bye bye. And if you are new to the channel, then please subscribe. Bye.